In our last episode, we heard Dexter's simple but striking belief that people eat too much, but they eat themselves into the grave. It's a sentiment that feels, well, almost old-fashioned, but it raises a question that modern science is still trying to answer. Could Dexter have been right? For as long as we've been human, we've searched for the secret to a longer life. Some look at genes, some look to exercise or mindset. But what if the key isn't found in what we do, but in what we don't do? Across the animal kingdom, from worms to monkeys, one pattern keeps reappearing. Eat less, live longer. But does that same rule apply to us? Or is calorie restriction just another scientific mirage, a promise that fades under the microscope of real life? In this episode of Chasing Dexter, we'll explore how our dietary habits may shape not just how long we live, but how well. Hi, my name's Owen Virtue, and this is Chasing Dexter. The idea that eating less might help us live longer isn't new. The first real evidence came nearly a century ago from an American biochemist named Clive McCay. In the early 1930s, McCay and his colleagues at Cornell University began a series of experiments on laboratory rats. They fed one group a normal diet and the other group a diet with fewer calories, but still enough nutrients to stay healthy. The results were astonishing. The calorie-restricted rats didn't just live longer, they stayed healthier for longer too. McCay's findings, published in 1935, became the foundation for decades of research into calorie restriction and aging. And since then, the same pattern has been observed in species as diverse as worms, fruit flies, fish, and even yeast, all showing signs that eating less without malnutrition can slow the aging process. But what about humans? Well, that's where things get complicated. Large-scale studies like the CALERIE trial have begun to reveal some promising clues, showing improvements in blood sugar control, inflammation, and metabolism. But whether calorie restriction can truly extend human lifespan, that remains an open question. The main CALERIE trial, one of the most ambitious aging studies ever attempted, was launched in May of 2007, specifically to answer that question. In simple terms, they asked healthy adults to cut their calories by about 25% and then followed them for a full 2 years. And what they found was striking. These weren't mice or monkeys. These were real people living normal lives, and their bodies responded in ways that echoed the earlier animal research. Participants showed lower inflammation, improved insulin sensitivity, reduced risk markers for cardiovascular disease, better metabolic efficiency, and just as importantly, their resting metabolic rate slowed more than expected, a sign that the body had shifted into that same energy conservation mode seen in calorie-restricted animals. But here's the key. Despite all of these positive shifts, we still don't know if calorie restriction will actually make humans live longer. 2 years isn't long enough to answer a lifelong question, and humans are far more complicated genetically and socially than any laboratory animal. Still, CALERIE gave us something we'd never had before. Evidence that eating less can trigger the same biological pathways associated with longevity in other species. Now, whether that translates into more years or simply better is still a mystery we're trying to solve. To understand whether eating less can help us live longer, we need to look beyond the plate and into the cell. One of the most intriguing discoveries in aging research began not in humans, but in yeast. Scientists found that when they restricted calories in simple organisms, something remarkable happened. A gene called D-sir2 switched on. D-sir2 belongs to a family of genes we now call sirtuins, sometimes nicknamed the guardians of the genome. When activated, sirtuins help repair DNA, reduce cellular damage, and improve the way our bodies manage energy. In other words, eating less didn't just make these organisms leaner, it made their cells more resilient, and this pattern didn't stop with yeast. It appears in worms, in flies, in mice, and even in primates. Across species, calorie restriction seemed to trigger a survival mode, one that conserved energy, slowed aging processes, and activated longevity pathways like sirtuins. But here's the question that really matters. Do these same genes and pathways work the same way in humans? And if they do, How much of a difference can they actually make? Is it feasible or even possible for humans to adhere to such a stringent regimen? And critically, is it just calorie restriction that induces these metabolic benefits, or is it just part of the equation? There's actually another side to calorie restriction, a side we don't often hear about. Because while eating less can trigger biological changes linked to longevity, long-term calorie restriction in humans comes with real challenges. In the CALERIE trial, even under careful supervision, participants experienced drops in bone density, reductions in muscle mass, decreased thyroid activity, and feelings of cold, fatigue, and irritability. This makes sense. When the body believes food is scarce, it conserves energy wherever it can. For our ancestors, this was a survival advantage. But for people living in the modern world, especially older adults, a slower metabolism, weaker bones, and reduced muscle strength can become serious risks. And then there's the psychological side. Maintaining a 20 to 25% calorie deficit day after day, year after year, is extremely difficult. Most people find their hunger increases, their mood fluctuates, and their social life becomes constrained. In other words, what works in a laboratory doesn't always translate into real life. And that leads us to a bigger question. Is strict calorie restriction actually the key to a longer, healthier life? Or is it just one piece of a much larger puzzle? Because, as researchers have discovered, longevity isn't driven by any single factor. It's shaped by genetics, lifestyle, environment, mindset, and how our bodies respond to stress, not just how we eat. And while eating less can activate powerful cellular pathways, it can also reduce muscle mass, sap energy, and make it harder to stay active as we age. This raises a simple but important point. Living longer and/or better isn't just about eating less. It also includes what we eat, how we eat, and when we eat, along with a host of other unrelated factors. We'll dig deeper into these questions and more in our next episode. But in the meantime, like, subscribe, and comment below because your participation helps so much in spreading the message. Thank you for watching this episode of Chasing Dexter. I really do appreciate your support. I'll see you on the next very soon. Bye for now.